And I am live. That is cool. Today is 3rd of October 2025, Friday, and we will just do more of 1600 rated questions, and that is pretty cool. Yep, CP31, and today is also a contest on Sport Forces. So, yes, and currently the rating is 1936. Four more points required to get to a specialist from a pupil to like elevate a little bit. But this is going to be fun. Share square point, and there will be 3 hours for 8 problems. 3 hours for 8 problems, and let's see how it goes. And yes, yesterday there were like some problem with Code Forces server. So this one was in queue for a long time, but then it came out of queue and it was fun. Yeah, this was working, and this one was correct. So that is cool. But this one we were unable to do during the stream, but after that I read the editorial and yes, it was not very difficult. Yeah, not so the thing which we wait 3.1415, that is pi. And the thing which we didn't know while solving this, or which we were unable to figure out, was that we can treat each digit place individually and find the number of ways to distribute this each digit in three different variables a, b, c. Yeah, just do that and multiply the answers. Multiply the number of possibilities for this, for this, for this. Just multiply them with each other. And here, and this is CACS 1600. Uh, Question E, good triplets. And yes, so this part just finds answer for each digits individually from 0 to 9. And then this part, while n is there, finds the answer for the last digit, multiplies that by the actual answer which starts with 1 and returns the answer. So yeah, that is fine. That is like kind of cool. And with that, we will begin solving our third 1600 rated question. And with this, okay, I will do my best to do this in 30 to 40 minutes. And that will be cool. 30 to 40 minutes, right? Yes. We will do this question, whatever it is, in 30 to 40 minutes. Let's see. Cool. Okay. We have, let's say 40 minutes. 40 minutes maximum time. After 40 minutes, I don't think there is a point in thinking about the same question for more than 40 minutes, because yesterday we gave this question 2.5 hours, 2 hours and 30 minutes, and yeah, most of that time was just wasted. So we will be very discreet with this one. Cool. 40 minutes. Here we go. Recall that a string A is lexicographically smaller than B. We know how it is. Consider a sequence of strings S1, S2, Sn, each consisting of lowercase Latin letters. So we have n strings. String S1 is given explicitly, and all strings are generated according to the following rule. To obtain the string I, a character is removed from the last string in such a way that Si is lexicographically minimal. To create the ith string, something is removed from the previous string, a single character. A character is removed from the previous string in such a way that string Si is lexicographically minimal, like as small as can be. Okay, for example, if S1 equals this DACB, I think we can remove D and we will get ACB. If we were to remove A, then no, that is not good. If we were to remove B, that is also fine, but removing D is the best choice. Then string s2 equals acb, string s3 equals we remove c, yes, we remove c, and string s4 is a. Okay, after that we obtain the string. Okay, we concatenate these strings. S is the concatenation of all the strings. You need to output the character and pause of S. Okay. Okay, this is doable, of course. So S1 has 10 power 6 characters, and we will certainly not create the whole S string, which is the concatenation of all the strings, which is kind of bad. No, we do not do that. And pause, we have to return pause. Okay, consisting of lowercase Latin characters. Okay, so first, when pause is given, we have to identify which string are we currently at. And pause could ask us for the answer for the last string also. So we also need to find out a way to remove characters in a way that is good, that makes the string lexicographically good, lexicographically minimal. Additional constraint, sum of S1 over all test cases does not exceed 10 power 6 for each test case. Answer the character and position. Note that the answer between different test cases are not separated by space or line breaks. Okay, they are in a single continuum. Ninth character. So first of all, we have the task of figuring out in which string does this character lands in. So if the first string has a length of n, the next string is going to have a length of n minus 1, then a length of n minus 2, then a length of n minus 3, and we have to see our number pause. Where does it lie? So I don't think we should store these. There should be a mathematical formula, closed formula. If we reverse the thing, if we yes, if we reverse the string, yes, if we do reverse the string and we calculate the position in that sense, so we will have one character in the last string, two in the one second last, and three, then four, then five, and so on. And pause is going to start, and pause is like total sum, the length of the biggest string minus pause. This is the index in this sense. I think we can just iterate. Yep, take n, then n minus 1, n minus 3, and when this sum becomes bigger, then pause, we stop. Yeah, linear search. Yes, and I think that would be fine. That would be fine. And okay, so then we will be able to figure out which string are we at, how many characters we have removed, and also how many characters this string has. Then our task becomes to take the original string S and remove that many characters. If we are saying S0 is the original string and SI, so we have to remove I number of characters from this original string, and whatever string we get, its index, the xth character, we are going to return the xth character from this string that we get. And yes, that we can do that. Okay, so there are two parts. First, we have to break pause into two parts, I plus x, I into I plus x, yeah. I comma x. I is going to give us the string from which we have to return the xth character. So let's write code for breaking pause. Int n, and then the wait, not just directly the string and then the character. Yeah. And in pause can be also like very big. See in pause, and we will begin from long sm equals s dot size, and we will we will begin with equals 0 for int I. Yep. For I equals 0, I and pause smaller than sm if pause is at a boundary. So yeah, in that case also we will increase. Like if the original string has 3 characters, let's say A, B, and C, and pause equals 3, then we break. Pause equals 2, we break. So, and sum initially is equal to 0. So while pause is greater than sum, but if sum becomes greater than pause, let's say sum includes all the strings till now. If pause is here, here, or here, we break. Okay. So only less than while pause is greater than sum. What we'll do is I plus, yes, and here we will do sm plus equals s dot size minus I. And yeah, that is the only thing we have to do. Plus sum minus I, and then I will give us the index of the string that we have to go to. And how do we get the in the ith string, which character do we have to return? Here pause, let's say, is pointing here and sm would be pointing here. So since do we know the size of this string, then we can know the size of all these strings and we can subtract that and we will get x, the index of the character which we have to remove. Or we already have sum which is right here, and pause I is telling us which string are we at. Can we know the size of this string? Yes, we can. Uh, size of s minus I is the size of the ith string. So we know the size of this string, we know pause, we know total sum, we subtract from sum, from total sum, which is here at this boundary. From this, we will subtract this, we will get, well, we already have this, we'll get this, and from this, okay, yes, cool. And x is going to be 0 index, so minus 1 plus sm minus sm minus the length of the string, which is s dot size minus I. sm total sum minus the length of the string, which is size total size of the original string minus I, and yes, subtract this whole thing from pos. Okay, and we should be good. See out I space x. What do we have? We have minus 1. Minus 1 is not good. Here we are saying in the third string. Third is not good. 3 plus 2 plus 1, 6. I minus RS. Okay, so in the second string, give us the first character, which is only one character. Here in the second string, here when the total original length is 4, give us character with index 1. So A, B, C, D. Our original string was, that is just too small. Original string was A, B, C, D. Then we made, then we converted A, B, C, D and made A, B, C. Then we made A, B. Then we had A. That is good. Okay. That is good. Mm, yes. So here, this one is, that is like too big. Yo. Here, what do we have? This one is string number 0. This one is string number 2, 1, 2, and string number 3. What we want is in second string, return the character 1. Second string, character at index 1, B. So is B the correct answer for this? It is the correct answer. So that is good. Here in the first string, give us the first character. Okay. So at least X, I, and X are correct. Now, what we want is a way to find out the ith string. So how would we like to break these characters up? I think we first need the number of inversions for each character. Like if we were to sort this, wait, if we were to sort this whole string, then here we have D. Yes, this would be the sorted version of the string. B, A, C, A, D. So if we will our main goal is whenever we have a string s, our main goal would be, so there is some character, some character, some character, some character. We will look at the first character and we look at the second character. If the first character is bigger, is like yes, is bigger than the next character, then this is the character that we want to remove, and we will go forward and find whenever we do remove a character, we already have our new string. And in the next case, we will do the same thing and remove the first character that we see is bigger than the next character. Right, and when we have done that, like when we do not have any character in descending order, that is, this one is smaller than this one, which is smaller than this one, which is smaller than this one, which is smaller than this one, then we will start removing characters from the end. So I think we can just linearly go through the string, and whenever we see that the current, and since we already know we have to remove I number of characters, so we will keep account of how many characters we already have, or we can say while I is greater than 0, and whenever we remove a character we will do I minus minus. And so first our goal would be to see where the current character is and look at the next character, right? And if the current character is bigger than the next character, and our invariance is that this whole string on the left is in sorted order, in increasing ascending order. So our main hypothesis is that we will have our pointer, let's say x, at some point in the string here, let's say, and our main hypothesis is that the string till now in the left is in sorted order, and whenever we see that the next character is smaller, then we want to remove this. We can remove this, and we will keep removing from the left while this block is smaller. While this block is smaller, or either we have removed the number of strings that we want to remove, and that is nice. And the time complexity would also not be very big. We can use two pointers. One pointer would stay here and one pointer would keep moving to the left, and we will never go to the left. And when this thing is in sorted order, we will move this x pointer to the next one. Yes, and at most each element is only visited once. First, when our pointer was moving to the right, and second, when our second pointer was removing elements. That is the, yeah, those are the only times when pointer is pointing to some element. So the time complexity is also not very big. So that looks good. That like actually looks good. Okay. So now while I need to remove I number of things. Okay, let's say L equals 0, R equals 0. L and R are initially both equal to, we don't even need R. Let's say X is our pointer. And first we will remove all the characters which are out of order. Hmm. Shit, we don't even need that. If we were to use a policy-based data structure, we could make this left pointer moving to the left a log time thing. But yes, no, we don't want to do that. Okay, and no character. We'll say char no c, as in no character. We are representing a no character by 0, by a literal 0. And whenever we remove a character, since removing a character from a string can be costly, we are going to replace that by this value, no c. And yes, that would represent that there is no character at this place. Move to the next place. Okay, so yes, okay. For x equals 0, which it already is equal to 0, and x less than s dot size minus 1 x plus plus. We will not go to the last character, and if the current character, which is sx, is greater than the next character, when it is And is it like the best, this greedy strategy, is it always the best? Like if, yes, it is always the best. That is how you define lexicographically smallest. But then when the characters are in ascending order of their thing, of their value, or maybe at points even same, then is it best to remove this? Yes, it is best to remove this. Yes. Yes, it is best to remove that character. If the current character is greater than the next character, and yes, also with this thing, we have to know that and I, like I is positive. So we would like to remove the current character and the characters moving leftward. So we will create a pointer called L, which is currently equal to X, and it will keep moving left. So while I is positive and while L is greater than equal to 0. And do we need to know anything else? Yes, we do need to know. We need to see if L is greater than S X plus 1. While this is true, what we will do is we will remove this SL character by making SL equals no C and I minus minus, since we removed one character, and L minus minus to move left. And that is very good. Okay, that is very good. Okay, and yes, why did I say while I, that like does not make sense. Okay, that is done. We have removed all the characters which were in like inverted, which were not in ascending order. Now, if I still exists, or yeah, we can say while I exists, if I is 0, then we won't go inside this loop, so that is fine. Wait, and shit. Also do this, but if SL, if the character on the left equals is not equal to no C, only then in decrease I. We do not want to remove a character twice and count it twice. So yeah, that is why we do that. And now I, we still need to remove some characters, but we have already removed the best ones. So we will start moving from the right. While I r equals s dot size minus 1. Or we can have a loop for n r equals s dot size minus 1, and our condition is while I is positive and r greater than equal to 0. R minus minus, what we will do is yes, wait, if we are removing characters from the right, we don't even have to remove characters from the right, we can just return, but we can actually just return. Now we need to return shit shit. So okay, we are not going to use x. Let's say int x was internally used here, not even x. Let's say shit, x is not a good choice. Substitute x with, let's say, j. Substitute with the last thing with j global. substitute J globally. Substitute X with J globally. Okay, fine. We have to now return the Xth character. Okay, for int I equals 0, I less than int J equals 0. Okay, and while J is smaller than X. No, shit. No, 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 no. We need while X. While X, what we will do is while Sj equals no C J plus plus. Keep moving to the next character. And after that, do X minus 9. C out Sj. Okay, S dot size. Okay, that is our function. Twenty FZ, that is a function, and also just C out Sj. And when we have solved all the things, see out a new line. And this should work, or maybe not. AX, we are not outputting B. Hello, a fellow Wimmer here. Hello, Wimmer. Ready for contest? Yes. Yesterday's problem? Yes, I did. I just figured that problem after you ended the stream. We were so close. Yes, I knew there was connection. I randomly did. 9 equals 3 into 3. Yes, it was like working, but we didn't know why it was working. And then I read the editorial and it made sense. Each of the digits in n are separate from each other. I saw table 1 to 9. Answer was like, shit, that's the pattern. Yeah, we just multiply the answer for each digit. Like, what is the number of ways to distribute one? What is the answer for 2? What is the answer for 3? And keep taking the last digit from n and multiply all of them together. Yeah, they were just independent of each other. And this is somehow wrong. Okay, in this, everything is okay. What is the value of x is a good question. Okay, we have x. So x was 0 for this A and x was 1 for this A. So answer should have been B for index at place 1. So why was it not? So if x is 0, we need to J right here is that is a nice point. J right here is not we do x minus minus, and then we also have to do j minus minus. Not the first time, but starting from the second time. If x is 1, we have to move forward. J by 1. If x j plus plus. If x is 0, we already are there. If x was 1 initially before getting into this while loop, which it will be at least, x will always be at least equal to 0. This will return the right answer. And yes, my bad, sorry. This is the question that we are doing. This question, and this is nice. This is a nice question. 32 minutes, and I think I got this. While x is 1, at the end of this loop, we are pointing at a character which we can use. Okay, and we reduce x by 1. But if there is some x that we need to explore, then we go to the next character. And by this loop, yeah, so yes. Behold, okay, right, accepted. Okay, okay, okay. I think this is going to work. Is there any like tricky thing which, because I want to get this right in first try. For each test case, print the answer, the character at position pause in string s. Note that the answers between different test cases are not separated by space or line breaks. Okay. At most we have 10 power 4 test cases. I think we are happy. Okay, let's submit. Let's submit, and then we will rewrite the code. Let's submit this. Okay, 1600. Wait, okay, let me rewrite the code. I do not feel confident. Okay, what do we have? First of all, we have the string s. We are taking in s. Now, there is a number pos. We take in pos, and pos is pointing to the index of the character that we have to remove from a new string s with the capital S, which will form according to these rules, right? Yeah, this new S string, and pos is the index which we need to return from this new S string. So first, we can divide this problem into two parts. First of all, since we have pos, we want to know the SIth string from which we have to return the character, and also we need to know in this SI string there are going to be some character, the index of the character from this string that we have to return, right? This is the first part, and the second part for solving this question is, once we know which string and which character we need from that string, then our second task would be to get the string si, and when we have the string si, we just return its x character. So let's focus on part 1 first. So here we have pause, and we can say long fm equals 0, and while, or not while, and I equals 0 for, yeah, for nothing. While pause is greater than sm, we will do I plus plus, and sm plus equals s dot size minus I. So if we have n equals 4, then Sm will become first equal to 4, then it will become 7, then Sm will become 9, then Sm will become 11, and then 12. And yeah, we will keep increasing Sm while pos is greater than Sm. And if at some point pos is equal to Sm or pos is smaller than Sm, then we break, and I is pointing to the string, to the index of the string, which we have to remove. But the thing is, when this condition is false, this statement runs every time. So we will have to do I minus minus to get the correct index of the string. Now we know the ith string from which we want the answer. Now in that string, which character do we have to remove? We will call it x, and let's find out x. X should be equal to, since we have pos, right? Since we have sum, which is greater than pos, and let's say pos in some example is 8, right? If pos is 8, then we can say that our sm is going to be 9 and our I is going to be in the 0, since answer was 4, 7 plus 3, 9. I is going to be 2. So x is going to be sm or pos minus, we will take sm and from sm subtract the length of the ith string, which is, and the length of the ith string, as we know, is s dot size minus I. That is the length of the ith string. From sm subtract that and subtract that whole thing from pos and do -1. Now we also have x and we also have I. So that is kind of nice. So what we have to do is return x star from I string. That is our goal. But to get that, we have to get the ith string. And now we will get the ith string. First, we will say, since we will have to remove quite a bit of characters from from the original string s, instead of actually removing them from the vector, we can say character no p or no c represents a 0 character. That is, there is no character at this location. So if we had original string like this, and let's say we wanted to remove the c character, we can just put, instead of c, 0 d. And whenever we see a 0, that it would just mean we are treating the string as if there are no zeros. And this is better than actually removing the c and making the string like this, because the time complexity would be bad when we want to remove some character in the middle of a vector. So yeah, that is why we have uh, no c. And as to our strategy for removing characters, we will begin from the beginning, and j less than s dot size -1 and j plus plus. What we will see is if the jth character are, we will have some invariance. Let's represent characters a b c as like numbers in ascending order, and what the invariance that we are going to follow is that, let's say j is pointing to some position in our vector, we will maintain that everything to the left of j is in ascending order. And whenever we see a character to the right of j at j plus 1, if that character is smaller than the current character, then we will start popping off these characters. We will keep moving left and we will pop off these characters because they are bad and they are the best way to remove a character. And yes, the time has gone over 40 minutes, but I think I got this right. And we will keep removing the characters while, since in total we need to remove I number of characters to get to the ith string. So we will keep removing these characters while I is true, and while this left pointer, let's represent this with L is greater than equal to 0, and this thing, this character that we are going to remove by replacing it with no C is greater than this j plus 1th character. And let's do that. So if the next character a s j plus 1 is smaller, not even equal, if it is exactly smaller than the current character, then we will have to remove some things. L equals j, and while I and while L greater than equal to 0, and while SL is greater, that is the character on the left is greater than Sj plus 1. And we are doing this to ensure, and when all of these characters have been removed, right, all of this is gone, then our new string would look something like this. And this red line is in ascending order. And then we will move on to our next j, which is j plus 1, this one. And we have maintained our invariance where everything to the left of j is in ascending order. Cool. So if L, so yeah, we have to remove the L character, and we will do it by replacing that with no C. That is one thing. And if S, shit, that was very stupid. If SL equals no C already, if SL is already equal to no C, then we will only do this. And yeah, we'll just move our pointer to the left. Else, if L was not equal to no C, then we will make it equal to no C, and, and decrease our number of characters which we have to remove by 1. And is there anything else we would like to do? Yes, L minus minus. Well, we are doing L minus minus in any case, so it can go out of the loop. L minus minus. And shit. Yeah, this is much better. If SL is not equal to no C, if we have not already removed this L character, then we will remove this L character and reduce our counter by 1. Cool. And after, and also, we will only keep doing this while I is positive and I. If I ever becomes 0, then no, we do not do anything. Now we have to return the xth character. Let's do x, or let's put our pointer j equal to 0, and we will move j to the first character that has not been removed. And how do we do that? We'll do that y s j equals no c, j plus plus. You might say, what if everything will never be removed? So j will always be something, right? And now we will say while x, since j is pointing to a character that is like that it has not been removed, what we'll do is x will do j plus plus, since we need some character from the right, and also x minus minus. We'll go to the next character that is not removed. And for this, we'll do this and x minus minus. And at the end, we will see out sj. That should be our correct answer. Okay. Okay. Mhm. The answer is wrong because of this. We do not have to print a new line. Okay, now the answer is correct, but is it always correct? Let's see. Okay, submit, submit, submit. Okay. Hello, what's up, bro? Like you are using brute force and making the string some other approach or some. I don't get this problem. Okay, wrong answer on test 2. Wrong. Wrong answer. Wrong. At least I think you would be able to get the part where we have to, the first part, we have to break pause into subsequent parts I and X, and then we will get to the ith string and return the Xth character from the string. Yo, hello, what's up? Can you share the workflow, like how you put questions in NewVim and test the solution? Yep, I can do that. I have a plugin in NewVim called Assistant NewVim. So in the NewVim side, all you have to do is add this plugin assistant.newvim, and on the browser side, you have to have this plugin called competitive companion, and also like, since this is NewVim, you will have to do some configuration where in assistant.newvim or whatever package you are using, you can modify the keys which open up that dialog box, and also you can modify the commands which you are using. Here I'm using G++15 version, so you can modify this to whatever you like, and then go to the problem, press the key which you specified. For me it is CPP, and then just press R to run the test case. I think I messed up here. Yeah, then pressed R to run the test case, and you will see AC or whatever. That is the whole workflow. But yo, okay, this is giving a wrong answer. We will not look at the wrong answer. I thought this should have worked. Is it guaranteed that pause is within the limits? This is maybe pause. Okay, pause is always within the limits, which is nice. So what is wrong? We need to make the string lexicographically smaller. So the approach, hello, yep, that is nice. The blur and the background, like the actual background, is this berserk, of course, guts. So since we have a string, let's represent the string in like a graph form like this. This is our string. And what does the height mean? Height just represents the weight, or you could say value of the character, where a equals 0, b equals 1, and z I think should be equal to 25. So height just represents the value of the character. And since we want to make this a string lexicographically smaller, shit, if I have a character here and I have a choice to remove it, I would only like to remove it if the next character is smaller than the current character. If the next character is smaller than the current character, so like here, let's say I have this character and the next character is has a smaller value, then if I remove this character, then this character would take its place and here I would have this smaller character. That is very good. But if, yes, so if we are just looking in terms of pairs, these are the only possibilities. The next one is greater, the next one has the same height, or the next one is smaller. So here, if I were to remove this character, then the string would become lexicographically bigger. We do not want that. No. If the heights are same, then if the heights are same, okay, we will come back to this point. But if the second character is smaller, I would like to have it first before this character. So let's remove this one. And that is the only time when we are removing. Whenever we see that the next character is smaller than the current character, we have a pointer L, which starts from the current character, which is greater than the next character. And while I is the number of characters that we have to remove, while I is positive, and L is greater than equal to 0, and Lth character is still greater than Sj plus 1. And I think this is very solid. This is true. And no C is representing that there is no character at this Lth location in S, because I do not want to literally remove a character. We are representing no character by no C value. So whenever we are removing a character, like here, if the current L character hasn't already, shit, that makes sense. That makes total sense. Do this while this. So while this is true, or the current character SL equals no C. That is also one possibility. Yes. And I think that was the only mistake. Yeah, I think that was the only mistake. Let's submit. Okay, let's again revise once more. So yeah, this I think the approach is pretty awesome. No, not yet, not yet. Almost, almost. Cody, what is Cody? Almost, almost. And today is a contest. We will see. We will see how things go. Yes, I'm like kind of afraid of today's contest, but we will see. I think this is correct. One step closer to 2000. Okay, 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 okay. Uh, mm, that is nice. That is very nice. Beautiful. Simply lovely. That is a reference to something. 55 minutes. Refresh. And we have this correct. Okay, that is actually pretty nice. That is like mm, very good. Very good. Yes. Okay. Refreshed. That is cool. And the rank is like it will be updated in a while. That is cool. That is very nice. We got the question. And yes, so first our strategy is, since we have this whole string S, we will begin iterating from the first. And whenever we see that the next and the invariance we will have a pointer, let's say j, which is moving through this string from the start, and the invariance which we have is from index 0 till j, the whole string is in ascending order. And whenever we see that this j plus 1th element is smaller than j, then we would like to remove the current element to get this one before we get jth element, and we will keep popping off elements from the left while this new j plus 1 element is greater, is like is smaller than this element on in the left. And yeah, and in total we just have to pop off I elements, and that is nice. Yes, so this was pretty cool. Let's see the tags. Tags, I think, are going to be 2 pointers. And I think we should be able to do this also with some, will you stream the contest too? No, it is like illegal to stream the contest against code forces things. So yeah, it is not good. And wait, is that shit your DP? That is her. Shit, that is literally her from the time travel anime. Yeah. Shit. And the main character, I forgot his name. The main character has had a choice either to save her, this woman, or to save his best friend. And yeah, it was a very nice anime. I even don't remember the name of the anime. But yeah, that anime was pretty cool. Let's see the tags. Yes, I guess that the tags are going to be 2 pointers. And yeah, 2 pointers, constructive algorithm, implementation strings, nothing. Implementation and strings. Okay. This was question number C, decreasing string. Let's see. Let's analyze in which order the characters should be removed from the given string. Suppose we want to remove a character so that the resulting string is lexicographically smallest. Yes, we can show that the best option is to find the leftmost pair of adjacent elements Si and Si plus 1 such that Si, that is the value on the left, is greater than the value on the right, and that is exactly what we do. Removing Si will decrease the character on the ith position because Si plus 1 will take Si's position if we remove Si. If you remove some characters to the right of Si, the ith character won't decrease, and if you remove some characters to the left of Si, you might accidentally increase some character before ith position. We choose the leftmost such pair, so the prefix until Si is non-descending, yes, ascending. If there is no such pair of the adjacent elements, you should keep removing the last character. Yes, unfortunately, implementing it so naively is slow. The solution will work in n square time. Thankfully, there is a way to determine in which all characters are removed in O of n. Yes, that is exactly what we are doing. All characters will be removed in constant time. Yes. Steins Gate. Yes. Steins Gate. Steins Gate. It is an amazing anime. Steins Gate is. I think is it an anime or a full movie? Yeah, it is an anime, I think, and not even very long. That is the one. Steins Gate. One season. And how many episodes? 24. Shit, this is long. Shit, this was very long ago. I watched this, yeah, in Corona. Maintain a stack of characters initially empty and iterate over the string from left to right. Whenever you encounter a character, if the stack is empty, oh yes, we could also have used the stack implementation. That also makes sense. Whenever the stack is empty or the character on the top is not greater than the current one, you don't have to remove any character, just push the new character into the stack. But if the character on the top of the stack is greater than the new one, if the character on top of the stack is greater than the new one, then we pop that character. Then we have found a pair of adjacent characters which meet the condition. So the character on the top of the stack is next to remove. Pop the topmost character of the stack. Note that we don't push the new character into the stack yet because the next element on the top of the stack might still be greater. In that case, this is the next character to remove, and we pop it and so on. In the end, the character in the stack will be non-descending from bottom to of the stack to the top, and we should remove from top to bottom. That is how we can find in which order characters are removed. Okay, the rest is quite easy. Locate in which of the strings the good pause occurs and remove the required number of characters and then print the corresponding character from the resulting string. Yes, minor detail which can make the implementation easier. If you append some characters which is less than a to the end of the given string, you don't have to consider the case when there is no pair of adjacent characters. That makes sense. That does make sense. That does make sense actually. Oh, he streamed daily and it is random CF question and he's solving CP31 which has rated category of problems. Yep. Should IIT go from the IIT go? That is crazy. Code Geass was up. OP, yes. King Lelouch. Lelouch Britannia 17. Code Geass is amazing. And the ending is one of the best. I create worlds, I destroy worlds. Yeah. The monster Lelouch is dead. Okay, 217. And now question number 4. Stopwatch. We have done one question. And how long has it been? It has been 1 hour and 7 minutes. Okay, for the next question also, I will take a target of 40 minutes and we will do this in 40 minutes. Big three, One Piece Gintama, Naruto and One Piece are there. I think the third one is Bleach and not Gintama. Yeah, One Piece is amazing. Uh, Naruto is good, but yeah, One Piece is pretty good, and Gintama is one of the best. Now 40 minutes for this question. For the next question to become max. Okay, cool. You are given an array A of length n. In one operation, you can choose an index I such that it is yes, not the last character, and A, the next character is either same or greater than I, and increase I by 1. Find the maximum possible value of this that you can get after performing this operation at max k times. Maximum possible value k times. That is a good question. We would like to put all of these k's on. This is a good question. This is actually a good question. If the next element is greater, so the only time, let's say we have some maximum element, right? We find the element that is maximum, the biggest element in the whole array. And the element before it is going to be smaller than this. And let's say we do enough operations to make these two equal to each other. And here, if the next element is also equal to the current element, that is when these two are equal, we can increase this one and make this one greater than this one. So the maximum answer that we can hope to get is going to be the maximum element plus 1. But we have a condition that k should be, let's say this one has a value of a, this one has a value of b, then k should be greater than equal to a minus b. Yes, if k is greater than equal to a minus b, that is a minus b, then like literally greater than a minus b. Shit, not even that. Not even that. We can have a bigger value. We can actually have a bigger value. Since now this element, let's say maximum was mx. This b value is now mx plus 1. And whatever the value before that number is, we can increase this to be also equal to mx plus 1, and we will add 1 to this, and the biggest value we have is mx plus 2. So this additional thing mx plus c, which we have here, this c is can be at maximum the number of elements which are to the left of the greatest number. Yes. Yeah. So if we do have a method, Mhm. If we do have a method in which, let's say, we start incrementing every element to the left of the current element, right? If the left element is smaller than the current element, then there would be some value which we can gain, and the maximum value which we can get is the current element a I is 0 indexed, ai plus I. This is the maximum value that we can get for the ith element if everything to the left is in descending order. If everything to the left is in ascending order, only that, and that would depend on k. It would depend on k how much of I we can have, how much left can we go. Okay, okay. Naruto, One Piece, Bleach. Nah, yeah, Bleach is, yeah, we don't watch Bleach. We will have to see how much to the left we can go. But if there is some element that is bigger than the current element, oh, wait, if let's say our biggest element is this one, and this has the maximum value. Oh, shit. Okay. And then we have this element, which is mx minus 1. And also we have another element, which is also mx minus 1. And let's say we do one of the k operations here, and now these two are same. These two are same because this one was mx minus 1. This one was also mx minus 1. Now we increased this by 1 because this one and this one were the same. So these two are now same, and then we do the operation here once, and in just two operations we got a value mx plus 1. That is the maximum value in just two operations. So let's say what are the limits? K can be 10 power k, and n is 1000, so we can do n square. We can do n square. Should we can just brute force this? We can brute force. Literally, we can just brute force. Okay, yes, let's brute force. Wait, this question. Shit, I should have looked at this earlier. The limit, we can just brute force. What are the values n and k, and then the a value? n k and vector n a size n for int reference x and a, c and x. We have all the elements and okay, int mx equals 0. Not even 0. Yes, that is what we do. And let's say these are long. And I less than n less than n I plus plus. And we will not go to the first element and we will say mx is a1, a 0. Okay, and we will have a pointer j equals I minus 1. And we will keep performing this operation on the left elements. So while j, first of all, j has to be greater than equal to 0 and k is like, yeah, k is non-zero. So if the difference that we need shit. No, okay. We'll keep a counter the maximum element. MXC, yeah, current maximum. We will say it is AI. And now, if the element on the left, which is AJ, yes, AJ is smaller than or equal to MXC, else break, get out of this while loop. But yes, if the element on the left is smaller than or greater to the maximum value which we have, and now if k, okay, we will also have int kc as in like the current value of k, because we do not want to update change the original k value, kc and aj smaller than equal to mxc. We don't need this. Now if we are checking if kc is greater than or equal to what we need. What we need is mx minus c plus 1 minus aj. We have this value aj which we want to increase, and if that is possible we will do k c minus equals mx plus c plus 1 minus aj. That is how much of kc, current k value, we use to make this element on the left aj equal to mxc plus 1. Yes, and else we'll do k c equals 0 to like get out of the loop. And yes, whatever the also we have to update the maximum value mxc plus plus. And now mx equals maximum mxc or mx value. Is it done? While j greater than 0, kc equals k. The map. Yes, we don't even have to use long, but okay. Because the maximum value we can have is the current maximum value plus 1000 because there are only 1000 elements. Let's test. Okay, mx is this, and this should also be long. Okay, 179 is very amazing. 179 is amazing, but here we say 5, here we say 4, 8. 8 is quite unexpected. Here we say, here we are saying 5. This could become 4. Okay, that is pretty nice. And our KC would become, yes, answer should not be 5. KC is equal to K. K is equal to 4. AI, and while J is greater than equal to 0 and KC is positive, mx plus c, which is 3, 3 plus 1, 4, 4 minus the left value 3, 1. We just need 1, 1 minus AC. Okay, this is okay. See out mxc. CMP, and how is everything going? Chat. Hello. Hello, he's back. And yes, I am using your keybind, which is pretty okay. Okay, 455. No, 55 is not good. Who said 55 is good? KC? How is this possible? KC equals 0. MXC 4, 5, 4, 4 is correct, but 5, how is 5 correct? AJ is the number on the left. AJ is smaller than or equal to mx plus c, and that is nice. C out mx plus mxc plus 1. That is the maximum value we can get with the current mx minus AJ. Again, your keybind 1, and there are 3 numbers with k value equal to 4, 1, 3, 3. And we have 3, 4, then 4. 3, why do we have 3? 3 is not good. MXC is 3, 3. Yes, 3 is okay. 3 is okay. 3 is okay. 3. 3 is okay. But then, okay, something is wrong. Substitute long with int. Okay, substitute long with int. Okay, see how much we can get. Okay, j, the number on the left, but we are not changing j ever. That is nice. And the current maximum that we have is, yes, ai. And while j is greater than equal to 0 and kc, and the number on the left is less than or equal to mxc. Yes. Only then can we can we increase the number on the left. And here mxc should be 3 plus 1, 4, 4 minus the number on the left, which is 1. So 3. So kc should become equal to 1 and not this value. Let's output aj, comma, kc. Colon. No, no. The key bind 1, 3 elements with k equal to 4, 1, 3, 3. 1, 4, 1, 1. Yep. Uh, you could message me on WhatsApp. That would be much preferable. Just for entertainment. Are you guys for Grand Prix? Wait, Grand Prix. We have a Grand Prix here in India. That is kind of nice. This is our input when the current value is 1. Mx is 1. Okay, that is good. And then, okay, shit, I do see the mistake. I do see the mistake, and the mistake is j minus 1. We can remove everything else. And let's see. And answer is still wrong, only in one case. So that is good. That is good. Here we are saying that the answer is 6, but the actual answer is 7. So there is some other optimization. If we start, okay, we cannot increase this. So that is good. We cannot increase this. Okay, that is also one thing that we can do. That is also one thing. Here we can increase this 4, this one by 3, and we have only 3k value remaining. And now we can increase this 4. Yes, we can increase this 4 to be equal to 5, and we have now 2k values remaining. Then we can increase this, and this will become equal to 6. Now we have 1k value remaining, and we will increase this. That is very nice. So till now we have been asking, what if we increase all the values to the left of this current number? Yes, but I think we should also be asking, if I want to increase the current value by 1. No, 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 no. If you cannot increase the left value, we might want to increase the current value to be equal to the left value, and then keep increasing all the values. Okay, that is also one option that we could go by. Okay, okay, okay. That is also one value, one thing that we could go by. Yes. So if mxc or ai, the current value is smaller. Wait a minute. If the current value is smaller than the left value, then we will make these equal, and we will say mx. Okay, this shift just doesn't work. Mxc equals aj, and we do mx. No, we have to also decrease the value of kc. Kc by some amount. Kc would be reduced by how much sum do we have to use to make ai equal to aj, and that is this much. Let's see. This should have worked. Okay, mxc is aj, so this should be yes for like in the case that we are getting the wrong answer. uh, when I is equal at this current element and j is at this element, we see that aj is bigger than ai, and when we see that aj is bigger than ai, we will make our maximum equal to aj, and kc will be reduced by how much amount it was we required to make aj equal to ai. Okay, so kc initially was 6. It becomes equal to 4 minus 1, 3. I mean 6 minus 3, so 3. And j greater than equal to 0, and kc positive number, and yes, mxc is equal to aj. So we will go inside this loop, and we will see mxc and aj are initially equal to each other. So this term will return 1 and kc, and yes, I am using mouse in new web. I will go to help, I guess, for that. And kc is greater than equal to that, and we are doing this. Okay, and nothing is depending. So what is the problem? What is the problem here? What is the problem here? There's some problem here. Clang warnings. Clang warning is crazy. Wait, why do you use Clang? You should use G++. M1. M1. Yeah, the cheapest one. In the section majority set. Okay, this there is something which we are not doing. C out mx c, and space and k c and a dot and the key bind. One test case which has all of these 5 6 one test case which has 5 6 6 5 5 4 1 3 1 5. वो क्या है? Messed up a little bit. Well, even though I messed up, answer should be correct. The answer is 7. Wait, I am outputting 7. Okay, answer is correct. But there is a subtle mistake here. There is a subtle mistake in here. If this, and there is only like so much that we can increase the current number by, right? And it depends on the number on the right. Yes, it totally depends on the number on the right. So if we want to increase I, if I is and I is smaller, is like, yes, I is smaller than n total numbers, then the maximum value that I can have, AI can be equal to mx c. So we have to see now, do we have enough k? If k c greater than great great greater than or equal to how much, the maximum value that we can have is, but also this also depends on what is the next element. Here we do know that there is some element to the right. No, we do not know. We do not know that, because we only know if I is smaller than n minus 1. So we do know that there is a element to the right. Now we can only increase AI if AI plus 1, the element to the right, is greater than or equal to AI, right? And where is and with that, and the KC which we have is enough to make that increase. KC is greater than equal to make that increase. The maximum value we can have is AI plus 1. Do we need to increase by that much amount? We do not want to increase the current value by that much amount. No, we do not want to increase the current value by that much amount. We only want to make the current value equal, at least equal to the last value. So the next value is greater. Now, how much greater? The next value should be at least AI plus 1. The next value should be greater than or equal to the previous, the value that we need, which is a j minus 1. AI plus 1 should be at least equal to this much. And with that, we also want to know if KC is enough to make that change. KC is greater than or equal to this much change, and the change we need is a j minus AI minus 1. Okay, if all of that is true, then KC will be reduced minus from KC, AJ minus 1 minus AI, and also MX C equals KJ minus 1. Okay. Hmm. 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 Okay. Only in this one, the answer is correct. The answer is wrong. I is less than n minus 1. Yes, that is true. And AI, the next value is greater than. No, no, no. We do not want to know that. We do not want to know this. AI plus 1. The next value is greater than equal to at least AJ minus AJ. It- Uh, yes, AJ, and yes, and we have enough KC to do that thing. Shit. No, no, no. Shit, shit, shit. We will have to do some modifications. This is not good. You want him? Shit, what is happening? Sum of n numbers is odd. We cannot divide. Okay, I don't know what is going on here. If KC, shit, okay. There is some number. Okay, how much can we update the current element? And that makes sense. That makes sense. That makes sense. That makes like a lot of sense. How much can we update the current number? And if we are going to do that, then we need to do something with this part. After we have gone through this whole, okay, we can subtract this and that. Shit, this is much more complicated than I thought. Is it? We only increment a number which is to the right when we want to increment the current number. Here in this 3, we increment this number only because we want to increment this number, and we increment this number only because we want to increment this number. And we cannot increment the number on the right, like ever, the rightmost number ever. Right. Uh-huh. Okay, our solution works when the current number I is fixed. Okay, there are only 3 minutes remaining. Our solution only works when the current number I is fixed. Now I want to change this number, and the degree by which this current number can change depends on the next number. Current number can remain as it is, or it can go up to the next number plus 1. Like here, this one could have gone up to 6. Yes, and if k were higher, so when we do solve for 1, let's say this one was okay, no. For here, yes, here with the current number equal to 2, we cannot increase any number. We cannot increase any number. We can only increase when the numbers have the same value. So we can increase this number and make this a 2, make this a 3, then this, and make this a 4, and then this, and make this a 5. So when this current value was equal to 2, we increased all of these values. Okay, and this value for 2, we went to the left, and if we were to start with 3 as the current value, we here we went left till 3 elements, till 3 numbers, and if we increase the current value by 1, this value, then we would have to have our kc equal to, it would only benefit to increase the current value. So first of all, we will make the current value at least equal to this number on the left, and it would depend if the current value is already equal to the value on the left, or the current value is or on the value on the right. And when we have done that, we will see how much left can this go. And if we had, let's say, 6 here instead of 3, then we would use up 1k here, plus 1k here, plus 1k here, plus 1k here. In total, the numbers on the left plus the current plus 1 for the current number to represent the current number. 4 amount of k's would be required, and by that we will be increasing k by 1. Yes, and if it was any less, then we won't be increasing the maximum value. So k divided by this. Okay, okay, okay. If the next value is greater, then we do this. Left equals 0. We are here seeing how many numbers are there on the left and how many numbers are there on the left. For each j, did we remove some value? Okay, let's say no. And left equals 0. We only removed, did some operation on the left. If here, left plus plus, and mxc plus equals kc should not be equal to 0. We will just break after this. Yes, and plus equals minimum of kc divided by k left plus 1 plus 1 comma it also depends on the value on the right. If there is some value on the right, if I smaller than n minus 1, and I think we are very close to the actual answer. We are above, it has been more than 40 minutes. We are above time, but I think we got this. If there is a value on the right, only do this then. Remaining case e plus 1. AI plus 1 if there is a value on the right and AI plus 1, that value on the right is greater than or equal to AI minus AI plus 1. Okay, that does work. And I think it will work. This will work. This will work. Here we are taking n and k and then the whole array, and then we are initializing our maximum value to be equal to a0, which like okay. And then we are start iterating from the second element I equals 1, and then we start iterating from the left, and our maximum value which we can and we are saying that we will increase all the values to the left of I. Therefore, from j is our left pointer, and the maximum value which we have obtained till now is ai, and kc is the current value of k which is remaining. And we are seeing if the current element is smaller than the element to the left which we were wanting to increase, then we cannot increase this element. So in that case, and also there is some element to the right of I, then we might be able to increase AI by some amount, right? Yep, we might be able to increase AI by check. We might be able to increase AI by some amount, and the minimum amount that we want AI to be equal to is equal to AJ. And do we have enough KC to make AI equal to AJ? And if we do, then we do increase AI and KJ, and that is like pretty cool. So here, we do have to check something. We here are checking if I is not the last element, and also the value on the right is greater than AI, right? But then still we need to know we cannot just divide here by left plus 1, because that will not work in every case. That will not work in every case. This will only work not if AI plus 1 is greater than AI, but greater than AI minus 1, the number on the left. That solves all the problems. And also we have to see originally if AJ, if AJ, the number on the left, was greater than AI, and maybe we did some things in this part and we increased AI by some amount, then then we want AI to be updated to that value. So we should not use AI here. Instead, we should here have AI and let's have int o original AI, let's say mxc, and therefore here we are going to subtract this supposedly original AI and plus one, right? So here we know that the value on the right is greater than equal to the value on the left, and that is shit, but also that and we would only be able to increase if with this we have uh, AI plus 1, the value on the right, greater. Wait, it is already greater than the value on the left, called the current value. And yes, I'm being very abstract here. Hello, hi, I am doing great. How are you? I am new. How do you guys solve problems? I can not solve 900 rated problems. Okay, so here I am just solving some problems, and yeah, you guys are also thinking about the problems, but the more important thing other than that is that you are seeing me solve harder problem, more difficult problems, which are at 1600 rating. But earlier I was having difficulty. Just 3 months ago I was facing difficulty while solving 800 rated problems. The first problem in this sheet, Hanoi, halloumi boxes. Yeah, this one, I guess this took me 2 hours to solve. I don't know why, because yeah, and that was 3 months ago, and now I'm solving 600 rated problem. So that is good. Like that is like to show you that you can also do that. Division 2, let's spar round tomorrow if you are interested. Wait, division 2 tonight plus spar round tomorrow. Wait, today is division 2 contest in code forces. That is what I will be giving. And wait, tonight, by tonight you mean in a few hours in your time, because it is in the middle of the day right now for us here, 125. And yeah, so there is a contest on code forces which I will be giving 6 hours and 38 minutes, and it is going to be amazing. Yes, I might actually reach specialist 1400, and it will be cool. Let's see. I think this thing here should be working. Okay, okay, that is giving the right answer. What are all the edge? There are just a lot of edge cases in this one. Okay, first try, first try, first try, first try to become max. And if this doesn't work, I'll just look at the editorial. If this doesn't work, test 3. Yeah, I do not have a good feeling. Yes, shit. Okay. Yeah, we can look at the editorial now, I guess. There are 1000 elements, and these were the elements, and shit. My output is 0, 3, and the correct output is 0, 4. Hmm. Mm, shit. That is kind of shit. Okay. Unfair. Okay, so there is a little mistake. I'm messing around somewhere. Wait, I think it depends on this J. No, no, it does not depend on J. We are only increasing left when we go to the left. Yes. Shit. There is some little mistake, and I think it is fine. We can read the editorial now. This is fine. 53 minutes. That is a lot of time on a single question. And yeah, we have done good. Wrong answer on test 6. That is fine. Question number 6 to become max. Binary search on the answer. Check if the possible if it is possible to have a greater than x for some x. Binary search. Binary search. Binary search. That does make sense. Our maximum value can only increase by x. So if it is possible to have maximum of this greater than equal to x for some x. So our on x the lower limit for x is going to be the smallest element, and the higher limit for x is going to be the largest element, plus k. Yeah, and between left and right, this is like true, 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 and at some point it will become false. We just have to find the location of this x where we have the biggest x where we have a true. Okay, so this is like monotonous function in that sense. And for a given value of x, we can, if we want, we can take up to n square time to find if it is true or false. And how do we do that? We have our whole array a0, a1, a2 dot 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 till an, and we can have a pointer which starts moving from this place, and we ask the question, can we, since we want x, can we make this current number, this number equal to x? To make this number increased by x, we would like to make the next to make this number at least be equal to x. We want. Okay, if the current number is already like greater than x, then okay, we can just return true. But if the current number is smaller than x, then what we want is we want to make the next number equal to x minus 1, the next number equal to x minus 2, and while we are doing this, we will keep removing how much we need to make these numbers equal to this much from k. And yeah, if you can go along the whole way making these numbers equal to whatever we need to make them equal to, we will have our answer, and then we can move on to the next question, next number, and ask the same question if we were unable to make the last number equal to x. Okay. Is possible. Bool is possible. This takes in a value x and a value k and our whole vector int integer vector a, a reference to the vector. Bool false equals initially false and return false, or return false, and if at some point we see that it is possible to do this, what we are trying to do, then okay, I equals 0, I less than n, I plus plus. Now if ai ck equals k, if ai is greater than or equal to x, the number that we need, then return x. But if this is not possible, else then return true. But if that is not possible, then we would like to increase this number, okay, and we will start a loop. If I is smaller than, or we can say j equals I plus 1, and we can have a loop here where we will be checking a few conditions. First of all, uh, j is smaller, j is smaller than n. What is n? That is a good question. And n equals a dot size. And with that, int n is smaller, j is smaller, the number on the right is smaller than n, that is we are within the vector. And also, okay, so okay, and we need j to be equal to something. Let's say current x is x minus 1, current x is x minus 1, and current k will be reduced by some amount, k minus, from k subtract, from current k subtract how much is required ai minus to make ai equal to x, or x minus ai, since ai is smaller than x, right? So ck, current value of k, is greater than 0, that is it is positive, right? And yes, that is kind of enough. With that, we want the next value aj to be equal to c minus x, right? So let's see if c minus k greater than equal to the value, how much of it is required, x c, x c is the value that we want, the next value, that is j, to be equal to. First of all, we will see if aj is already equal to or greater than or equal to the current x that it is required to be, then we will just return true. Else, if aj is smaller than ck, then we need to see the value of current c. If current if current k is greater than, or if current k is greater than or equal to the value that is required, and the value that is required is x, current x minus the value that is, which is a aj. If that is true, then we will update aj, ck from ck. Hmm. Okay, no matter, we will not check this condition. We will just remove ck, minus what is required, and what is required is cx minus aj. And if ck is greater than or equal to 0, greater than equal to 0, then return true. I think that should work. That should work. That like kind of should work, I think. Now for int n and k seen n and k and taken n and k, it has been long seen n and k, and what is the minimum value of x, what are the left and right limits. We will create a vector a size n, and for int I equals 0, I less than, the keyboard is messed up, less than n, I plus plus. Take the current value in ai, and we will find the minimum and the maximum value. L is int max, and right is 0 initially, and L equals minimum of L or the current value, and R is maximum of the current value plus 1000. Yeah, R comma AR. R plus equals 1 to 3000, and we know that L is always possible, R is never possible. So while L R minus L is greater than 1 when the range is at least 1. M mid is equal to L plus R, R minus L. R minus L divided by 2. Yes, and if this M is possible, if, what is the name of the function, is pos. If is pos, what are the things that we have to give into the function? First, x is M, then k, and then a, the whole vector. If it is possible to have this, then L equals M. But if it is not possible to have this value, then we will say R equals M. And at the end, see out L. And this should, in theory, work. Wrong answer, wrong answer, wrong answer on all of them. Shit. Wrong. How is this thing true? 190. How did we even get 192 here? L is equal to minimum of these values, and L is always possible. Something is wrong with R is possible function. N plus N. Yeah. 192 plus 3. Why is this thing returning true for 192? In this case, why is this thing returning true for 192? While k is only equal to 13. When we are at the last element, let's say, okay, this makes sense. This makes sense. This statement makes a lot of sense. If the current number is greater, shit. What if J returned and yes, okay, so shit, this is like wrong in a lot of ways. Shit, this is completely wrong. Okay, I think I should skip this question for now. What's this Kufu's handle? Yo, just my name. From where are the problems? The problems are from this sheet, CP31, and my code forces handle, like literally a handle, is this just my name. And yes, I think we can put this question in review for now. Question number 16. Yeah, so not bad. This is fine. I think this is fine. 1 hour and 11 minutes. And now the next question is going to be tracking segments, and we will go back to that question. Yeah, I'll do that on my own later at some point. But yeah, now let's move on to the next question, because it is not very a brilliant idea to spend more than 1 hour on a question. Yeah, So this is the next question we will be doing. Let's see. Yeah, that is blur background. You can solve the question side by side. That would be pretty nice if you want to. This is the next question. And let's, okay, that is something. Let's do this. 1600 rated. Okay. You are given an array A consisting of n zeros. You are also given a set of m, not necessarily different segments, a set of m segments which might not be different. Each segment is defined by two numbers, okay, L and R, and represents a subarray in this range where L and R are both included. Let's call the segment L R beautiful if the number of ones in this segment is strictly greater than the number of zeros. Okay, so is our array only consisting of zeros and ones? If the number of ones is strictly greater than the number of zeros. For example, if this, then the segment 1, 2, 5 is beautiful because we have three ones and only two zeros. The number of ones is 3 and the number of zeros is 2. But the segment 3 to 4, which is this, is not beautiful because the number of ones is 1 and the number of zeros is also 1. You also have Q queries. For each change you are given tracking segments. For each change you are given the number x, which means you must assign an element ax the value 1. You have to find the first change after which at least one of the m segments become beautiful, or report that none of them is beautiful after processing all Q changes. Shit. Okay. Okay. Shit, that is crazy. That is a good question. 10 power 5. There are in total 10 power 5 numbers, and segments can also be the same thing. And then L and R, and then Q, there are going to be at least n queries. Okay, and then the Q lines follow. And okay, how does our array look like initially? N equals 5, and then also M equals 5. N and M, we have total 5 elements, and there are 5 segments. These are the 5 segments: 1, 2, 3, 4, 5. And then we have 5 queries, which is change the one at index this, change the one at index this, and this. Okay, and you also have Q queries for each query, which means you must assign an element AX the value 1. So I believe initially we start with array where all the values are equal to 0. And for each segment, we can keep some amount which would represent how many ones are required in that segment to make it beautiful. But then this is not really good. Let's write this down. We have 5 elements, right? Yes. 0, 0, 0, 0, 0. We have 5 elements. And how do our segments look like? These are our segments. One segment from 1 to 2. This is one segment. Then we have another segment 4 to 5. This segment. Then we have another segment 1 to 5, the whole array. and we have another segment 1 to 3. 1 2 3. Then we have another segment 2 to 4. 2 to 4, and this is another segment. And yes, and now we have 5 queries. This one says to change the number at index 5 to be equal to 1. So this is 1, and this does not help any of the segment to make them true. So yeah, for this query we change the number at index 3, this one equal to 1, and this also, no segment is beautiful. And then we change the number at this place. Now this brown segment is beautiful, and we return 3 because we did this on the third query. Okay, let's number these segments. This one is segment 1, this 2, this is 3, this is 4, this is 5. And since this is inclusive, for each segment initially we will need the right limit minus the left limit plus 1. That is how many elements there are in total. Now plus 1 or plus 2 divided by 2. This is how many ones we need. Yes, that is how many ones we need. Yes, that is how many ones we need. If the total number of numbers is 2, then we need 2 ones, because when we add 2 and divide by 2, we will get 2. When the total number of numbers is 3, we will add 2, this will become 5. 5 by 2 is also 2, and that is true. And when the number is like 4, we add 2 and divide by 2, we get 3, and 3 is more than half of the original numbers in the segment. So that is good. So right minus left plus 3 divided by 2. Here right minus left 1 plus 3 4, 4 by 2 2. For the second segment we need 4 5 1, yeah, the same thing, 2. For the third segment we have 4 plus 3 7 by 2 3. And then for the fourth segment, this one 2 plus 2 4 by 2 2. And for the fifth segment we have 2 plus 2 plus 2 2 plus 2 4 divided by 2 2. This is how many ones we need. And whenever we see a query, this one is our first query, we update this value. So how do we go about updating these whenever we see a query? Segment trees. I mean, it in the question does say segment. And whenever we see a query, we do not want to go through all the segments and see if like if we have enough number of ones for this current segment. That is not good. Wait, is this can we use binary search for a cert, like initially we will start with 0 queries, and we will have uh, let's, yeah, it might be the case that even after all the queries have been done, the answer is false. Yeah, but let's say hopefully we have answer for at the start of the queries. When we have not done any queries, the answer is false. Then it will remain false for some while, and then it will turn true. We need to return this index I uh, where like for this many queries one of the segments became beautiful. And to know this, we can actually take n time. Okay, we can actually take n time to do this thing. And let's say we do go through all the queries till this point and we update our array, right? That would take us some big O of Q amount of time. And then we go through all the segments and see, is this segment okay or not? And to quickly check if the current segment is beautiful or not, we need to know the number of zeros and ones in that segment. We can do this by beforehand making a prefix of zeros and ones, or we can work with a single prefix. Yes, we can work with a single prefix in which we will contain the net amount of ones. Whenever we see a 1, we will increase the answer by 1, and whenever we see a 0, we will reduce the answer by 1. Yeah, the previous value by 1. And we can do that in log n time, and then we can go through all the segments which are going to be at max n. There are going to be at max n segments. So going through all the segments will take us n time. So in total, the time complexity is going to be n, and that is good. That is good. And our L will begin at the first query, and our write will begin at the last query, Q. Yes. Yes. And we will go through query from query number 1 to L, and first update the whole array, then make a prefix for that and see if is there a segment that is like beautiful. And that is okay. That is okay. And what is our range going to be? Our range will be L to R. And if at some point we see that L equals R, then our range consists of only a single value. Our range consists only of a single value, and yes, uh, our we can first of all run this for Q, and yes, for Q, or we can take R as like R is always true, and we can assume we can initialize R at Q plus 1. Yes, we can initialize R at Q plus 1, and whenever we ask the answer for Q plus 1, we will return true. Right, so R is always true, R is always true, and L is always false. And we can begin L as L minus 1, and whenever we ask the answer for 0, L will begin at 0. Whenever we ask the answer for 0, we will return false. Yeah, none of the segments is beautiful. And yes, initially none of them actually is beautiful, so that also works. Hello. Yes, CP31. CP31 is the main source. for the questions. Currently, we are at this question. We skipped this one because, yeah, not right now. Let's solve. CP31, boilerplate. Okay. Int n and k is what we get, and yes, then we will get the k queries or the k segments, which we will store in a vector of pairs. And yes, we will call this seg, and there are going to be n elements in this segment. That is nice. We will also initialize the pair. For int I equals 0, I less than k, k I plus plus, and cn seg I dot first into seg I dot second. We have taken all the things, and let's now say q. We have all the segments taken q, and now we will take all the queries vector pair vector int queries are singular numbers where, and there are in total q number of queries for int reference x in where, like, yes, where cn x. And yes, now we will say that our left limit initially is equal to 0 and our right limit is equal to q plus 1. And we will also need a function here which returns a boolean value is beautiful and it will take some value m, and it will take all the segments vector of pairs int reference, and it will be called seg, and it will also take in all the query which is a vector of integers reference, and we will call it square. Okay, m seg and square. And do we need anything else? Nope, we do not need anything else. So now we will process all of these queries from 0 till m, but before that we have some edge conditions. If m, if not m, if m is 0, we have defined that as false. Return false, nothing is beautiful at the start. And if like m greater than the number of queries dot size, then return true. We'll consider that as beautiful. But if we are in the middle, then we will have to do something. We will create vector bool q or a of size n. What is n? That is our like good question. Shit. Yes. Okay. Shit. This function also needs n. Int n. Not here. The start. The size here is n. And initially everything is false. So that is good. And then we will go through all the queries for int x and q where and queries are one indexed, so x minus 1 equals true. And after this, we will create a prefix vector and ref of size n plus 1, and for int I equals 0, I equals 0, I less than n I plus plus ref I plus 1 equals ref I plus, depending on what the current AI is. If AI question mark, if AI is 0, then we subtract 1, and if AI is 1, then we add 1. So if AI is 1, then we add 1, but if AI is 0, then we minus 1. Now we have created the prefix. Also, now we need to go through all the segments. For auto x comma y in the segments, for auto x comma y in the segments, and we will initially here return false, and if we ever find that the current segment is beautiful, then okay, true. Now how do we see if this segment beginning from x and y is beautiful? First, we need the number of ones, and the number of ones is pref y minus pref x minus 1. That is the number of ones in this segment. And is that correct? That is very much correct. Yes, that is correct. That is the number of ones. And how many ones do we need? If number of ones that are in the segment is greater than equal to the number of ones that we need, and the number of ones that we need in this segment is y minus x, the right limit minus the left limit, plus 3, not 2, plus 3, and the whole thing, this whole thing divided by 2. That is how many ones we need. And if this thing is true, then return true. Okay, that should be correct. And just in case, let's put a bracket here. Okay. Yes. So this function, the time complexity for this function is big O of n, and that is acceptable. Why is it big O of n? Because here we are going through the queries which are at max n linearly, and then we are going through and making a prefix, so that is also n time. And here also there can be at maximum n number of segments, so that is also n. So the total time complexity is n plus n plus n. But what I'm afraid of is the constant factors. Here we are creating a new vector every time, not just one, two vectors, which might not be a very good idea. I think, yeah, we might be able to. No, 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 no. We cannot sort the queries. So yeah, shit. This is where we do not want to go through all the queries. My bad. Shit. And I equals 0, I less than query dot size, not query dot size. Uh, I less than the number of queries that we want to go to, and that is m minus 1. Yeah, and bracket I plus plus. And this should, yes, this is correct. This seems correct. Is beautiful function is kind of correct. And while r minus l, which is our range, we know that r is initially correct and l is initially false. So r minus l is, our range is greater than 1. While this is true, let's get m equals l plus r minus l divided by 2. And if is beautiful, this m, if okay, we have to give m, we have to give n, the original size, and we have to give the segments, and we have to give the queries. If this is beautiful, then like that is pretty cool. If this is beautiful, then r equals m, because r is always true. Else, if that is not beautiful, then L equals M. And at the end, if we see R is going to be the smallest value, that is true. So if R is greater than, or if R is, yeah, if greater than Q, then R is greater than Q, then C out -1 with a new line, because like that is not possible. Else C out R. Okay, that is messed up. X was not declared in line number 13. That is a good question. What is X? X is where I. Out of bounds. Okay, I will go to the washroom and I will be right back in a minute. Just a minute, I'll be right back. Yes. I'm back and let's get this done. 27 minutes. Okay, we can do this. The time limit is 40 minutes. Let's do this. And like before that. Okay, so out of bounds. Out of bounds. There is no problem with this. Like, what is the problem? Yes, there is no problem here while we are taking the input, and also there is no problem here while we are taking the input. There are going to be k segments, yes, but yeah, that should not be the problem. Yeah, there is some problem here. First we have m and then we have n. Yes, first we have m, then n, then seg, and then query. Okay, then segments, then query. If m is 0, return false. If m is greater than the size of the queries, then return true. Else, if vector, then we create a vector of size n, a, everything is initially false, that is 0, and we create a prefix of integers of size n plus 1. Okay, cool. Right. And here we have I equals 0 less than m minus 1. That is how many segments, that is how many queries we have to go through. And we know m less than y m minus 1 less than m. Yeah, we have to go through m queries, and we know m is not 0 and m is not greater than the size of the queries. So yes, this is cool. and we are making everything in this range for the current query equal to true. For the ith query, we are making whatever the index is of the ith query equal to true. And then we are creating the prefix. And the size of the prefix is n plus 1. So this is also cool. Prefix I plus 1 equals prefix I plus, depending on AI, if AI is true, if AI is 1, then we increase our prefix by 1. If AI is 0, then we decrease our prefix by 1. Now we are going through the segments and we are seeing, is there any segment which is true? X and Y, we are unbinding the segment here, the number of ones that we have here, and X and Y are one index. We have to keep that in mind. X and Y are one index, so Y will work because Y can at maximum be n plus 1, and that is okay because Y can at maximum be n. That is okay because our prefix has a size of n plus 1. That is okay, good. And X will be at minimum 1. So this should also not give any unbound out of bound error. So at which point are we getting the error? Cout 1, 1, end the line, and here's this, and this. Not 1, let's replace 1 with m here, and then here, and then here. Wait, yeah, yeah. If we go through this loop, we will see 1 at least once. If we see m twice, then we see this. Yeah. Okay, and let's say cout new line here, cmp for some input, let's say for this query. We have one test case. Okay, this, okay, we are looking for a vector that is very big. How? Do you see the error? Does anyone see the error here? Yes, the error is very stupid. We are not even taking the input. Ah, shit. Shit. Out of bounds and wrong answer. That is better than whatever we were seeing earlier. 4 minus 1, 1 minus 1, 4, 4, 4. Okay, so, okay, this minus 1 is bad, but everything else is kind of good. Why do we return 4 here? Let's output the values for the left values and the right values. We know the initial left and right values. Right. Okay. So first we had our left value increased and it became equal to 3. So for 3, wait, why did it become equal to 3? We got false for 3, which does not make sense. Initially m was equal to 3 and we called this function for m. For m equals 3. Okay. For m equals 3, this function returned false. That is not good. When the number of queries was 3, let's like execute this function manually. Yes, time is ticking. Yes. This is what we had for m equals to 3. We are here for m equals to 3. This thing is returning false. We here go through the queries, the first query, second query, and the query number 1, query number 0, query number 1, query number 2. Right? And we make in A all of these, all of those indexes equal to 1. So for query number this, and this, which is at index 1, then 0 at index 2, then at here 1, and then here 0, and then here 1. Yes, this is what we have. And then we create our prefix. And we are going through all the elements and prefix I plus 1 depending on the current element we are updating the last value. So prefix in prefix, let's say 0, index 0, 1, 2, 3, 4, and index 5. Initially the value is 0, right? For the next one we look at this thing, and this is 1, so we increase this by 1. And then we look at this, we decrease this by 1, and then we look at this and we increase this by 1. Shit. What even is this? The number of ones that we have. If ones is greater than 0, then return true. That should be the thing. Okay, wrong answer because we are outputting left and right index. Okay. That is working. That is working. Look at that. Look at this. Okay, this is working. This is working, and let's submit. Let's submit. Let's submit. And this one uses binary search with some basic prefix things. Okay. 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 Cool. That was the best question yet. Shit, that was good. That was good. 38 minutes to solve this question. 38 minutes is fine for a 1600 rated question. And the fact that we are even solving this question is good. Good enough. 38 minutes. That is nice. Reset and let's rewrite the solution once more for this question. And that is good. Accepted. Like that is pretty cool. Okay. Let's rewrite the solution and I will be going through what I have done here. Okay, so we have n, the number of elements, and we have k, which is the number of segments that we have. Then we take in n and we take in k, and we do not make the mistake of not taking them, not initializing these values. And then there are going to be some segments which we will store as pairs of integers. We will call this seg, and there are going to be k number of segments. And yeah, let's initialize each pair like this. Now, for int I equals 0, now we will take in the segment into our segment vector. And for this, we can simply do for auto reference x comma y in seg c in x and y. That is good. We have taken in the segment. Now there are a bunch of queries. To be exact, there are q number of queries. Vector in q. We will create a vector of size q, which will contain all the queries, and we will initialize our vector. We will take in all the values in q x. Yep, that is initialized. And now we are going to apply binary search. And there are some number of queries. Query 0, query number 1, query number 2, query number 3, dot 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 till query number q. Since there are q number of queries, and we are supposing, not that we are supposing, we are also having some imaginary queries. Query number 0, that is no query at all, and then query number q plus 1, and we are supposing that at query number 0, no segment is beautiful. So is beautiful is false. We have a function is beautiful which takes in number m, which is from the start we are taking m number of queries, and we are asking ourselves, is there a segment which is beautiful when we are only processing the first m queries? And yeah, that is what is beautiful function returns. And we are supposing that this q0 query, which does not exist, this always returns false. No segment is beautiful before we have processed any query. And this imaginary query, one past the last query, this we are supposing is always true. That is, when we have gone through all the queries and even one past the last query, then all the segments are true. Like we will just suppose that all the segments are true at that point. So we can start a binary search approach where our left limit will be equal to initially 0, which is this query, and our right limit will be equal to q plus 1, which is true. And what are our invariances? We will have some invariances, and the invariance is that L is always false, and R, this is R, this is not very beautiful, R is always true. So what is going to be our range? Our range is going to include L and go up to R. L is not included, like, because we know that L is false, so we do not want false. We want the first true. Things are like this, and at some point hopefully there is a true. We want the first q where we see a true. So our range, since L is false, we will not include L in our range, but R is always true, so we will include R in our range. And so the size of our range is R minus L. This is our size of the range, and we will run our loop while our range is greater than 1. If our range is 1, that is R plus R equals L plus 1. Our range has only one element, then we will process that element. And R, we will keep the invariance that R is always pointing to something that is true. And when we come out of our binary search, we will see, is the R element pointing to this imaginary element? And if it is pointing to this imaginary element, then it means we have processed all of these queries on the left, but we never got a true. The first true that we got was after processing all these queries at this imaginary query. So we were not able to make a beautiful segment even after processing all the queries. So we will return -1. But if R is not pointing to this imaginary place, then R is always pointing to the true that is to the leftmost. Yeah, and that is cool. So we will now initialize our ranges L equals 0 and R equals Q plus 1. And while we have R minus L, our range is greater than 1, we will run the loop. And M equals L plus R minus L divided by 2. And if is beautiful at this, when we have processed M queries, then R equals M. because it is beautiful. Else, if it is not beautiful, then L equals M. And yeah, we will write this is beautiful function in a while. And after that, if we have R equals Q plus 1 or R greater than Q, then we will output -1 with a new line. But if we have like something else, anything else, then we will just output R. Now we have to write R is beautiful function, which is going to return a bool, and this requires some numbers. This will take in M, the number of queries which we are processing. It will take in N, the total length of the array, and it will take in seg, like the segments, vector, pair, int, a reference, seg, and it will also take in the queries, vector of integers, reference, square. Now, if not M, if M is 0, we have decided we will return false, and if M equals, if M equals or M greater than square dot size, then return true, and that is nice. Now after this we will create our like array, vector, bool, a, size, n, and everything is initially false. Then we will process m number of queries. So for int I equals 0, in 0, I less than m, I plus plus, and we will say a I for the ith query, where I in a equals true. And since the indices in queries are one indexed, we -1 and do this. And we also need a prefix for checking if a current segment is like beautiful or not. So we will have a vector of integers, we'll call it ref size n plus 1, and we will fix our like fill our prefix I less than n, I plus plus, and ref I plus 1 equals ref I plus, depending on the current value in AI. If question mark, if AI is 1, then we increase by 1. If AI is 0, then we decrease by 1. And now we will be processing the queries for auto x comma y in seg. Not that we are processing the queries. Now we are going through all the segments and seeing if any one of them is beautiful. And at the end, we will just return false. Now, for the current segment, the number of ones is going to be ref y minus ref x minus 1. That is the number of ones we have, not the number of ones, but what is the extra number of ones which we have. And the number of ones is like greater than 0, not the total number of ones, but the amount of ones, number of ones minus the number of zeros is what we have here. And if the number of ones minus the number of zeros is greater than 0, then we return true. But if we have gone through all the segments and we did not find a single true, then we return false. And this should be correct. This is like the whole thing. Hello. Okay, you are back, and I have to say one thing. If you are like still here, you said that learn X in Y minutes is a scam. And no, I do not believe so. And let's bet. Let's have a bet. Yeah, okay, you are here. So let's have a bet. Not right now. Let's have a bet. No, it is not a scam. I will show you that it is not a scam. Not right now, but I will do a stream one day, someday, and I will Discord you. Yes, I will tell you on Discord beforehand when I will be doing that stream. And in that stream, you can tell me any language you want, and I will read its learn X in Y minutes and only that thing. And then we will do one advent of code question in that language, which I have no idea. And my only reference is going to be learn X in Y minutes. How is that? And if I am unable to do advent of code question, we will do this question, right? Whatever this is. And this is going to be hard because not because the question is hard, but because the input will be saved in a file and I will have to read text from a file from with this language, whatever the language would be that you tell. And yeah, so I will read about that language from learn in XY minutes, fix an error you wrote, return instead of return. Huh? No, it is fixed. Like no, that is fine. Shit, shit, I did mess up. There, vector. And how do you think about the bet? Where is the vector? Is beautiful M. Oh, okay. It needs a lot more things than just M. N seg square, right? That is cool. And what do you think about the bet? You can give me any language you want, and yeah, and yeah, just 100 rupees would be like fine. I think you can manage that with your Kinesis keyboard. And this is going to be cool shit. You could tell me any language here, at least a language in which we can solve some question, not like C CSS. CSS is does not make sense. A little more. Yeah, that was the last question. I would be ending a stream in a while. I mean, see, if you know one language, you can pick almost instantly. Okay, yes, that is the point. I can manage 1,000. It doesn't matter. Okay, you can. Yes, I think you can manage a lot. You have Kinesis keyboard. Yeah, if I know a language, I can pick any language and learn using learn X environment. But if I am a beginner, I cannot. Like learn X environment is very overwhelming if I am a beginner. If I do not know anything, if I don't even know what variables are, then it is not going to help. That yeah, that was the point. Shit, I think it must be here. Yeah, it is here. Kotlin. Latex is also there. Shit. You can choose randomly whenever I do the stream. And I think, yeah, I should have done. Okay, I should have done this when you said this the first time that it is a scam. I should have done a Rust question. That would have been pretty cool. But anyways, we did do this question, and that is very nice. Tracking segments in just 38 minutes. That is pretty cool. Let's predict or guess the tags. I think the tags are going to be binary search. Yes, binary search. Binary search is what we did. Binary search. Brute force, binary search, two pointers. Yes, cool. Data structure. And the editorial. This was question number E, tracking segments. I am going to pick assembly. You don't know. You don't know me, son. I can code in assembly. I can code in assembly. I have solved advent of code question in assembly, and I did assembly stream some days ago, not some day, maybe a month ago. Let me show you. But I would have to revise. Where is add-on of code? This one. And for which year? Okay, this is not the branch. For 2023, nope. 2024 maybe, I think. The year 2024, day 1, part 1. This is in JavaScript, part 1, and this took like 24 lines of code. But in assembly, yeah, this is part 1 in assembly. This took like 250 lines of code. Yeah, I can write in assembly. It is a good language, but once you get caught somewhere, you are dead instantly. I mean, writing assembly is very cool. You feel like a wizard, and you are like literally doing everything by hand. Here, putting store pointer, or more like store pair, whatever is in register number 29 and register number 30 onto the stack, and increase, decrease, subtract, stack whatever the stack pointer value is by 16, literal 16 bytes to get 16 bytes, because this register has values. The total content of this register, size of this register is 8 bytes, and for this register is also 8 bytes. So get some 16 bytes onto the stack and put the data of these two registers onto the stack, and yeah, that this is cool. But I have one advantage, that I have ARM architecture CPU, so this is RISC assembly, and that is better than x86. x84 assembly is like truly complex. It does say CISC, uh, complex instruction set architecture, and that is like very complex. Let's read the editorial. Division 3, question number E. Right. Tracking segments. Let us use a binary search for an answer. It will work because some segment, if some segment was good, then after one more change, it will not be no longer good. And if all segments were bad, then you remove the last change, they will remain bad. To check if there is a good segment for the prefix of changes, you can build the array obtained by these changes and then count the prefix sums. That is exactly what we did. After that, you can go through all the segments and check for the number of ones in the segment whether it is good or not. Yeah, that is exactly what we did, and that is fine. Easy. No, x86 is okay. I cannot say anything about it because I haven't done anything in x86. But yeah, this one was cool. We have done today this question, and this question we did in 55 minutes. That is okay. And this one in 38 minutes. Okay, improvement, but we were not able to do this question, and that is fine. That is fine. These days, I am wrapping my head around Kotlin. Ah, so what do you want to make Android apps? What are you doing? Like, and after learning, like whatever, I know you have learned a lot of things. You are into a lot of things. Okay, you don't like enjoy typing in JS shit. You have gone through a lot of things. You know about Linux. You know a lot about C and like what happens underneath. And I think that helps a lot when you are learning a new thing like Kotlin. You'd be able to instantly or quickly grasp what is happening in Kotlin, and that is very good. That is very good. And yes, shit, camera is messed up. That is fine. And for today, that would be the end of not the world, but for the stream. Yep, that would be the end of the stream for today. And yes, I am in college, Trevo. That would be the end of the stream for today. And thank you for being here. Bye. We did 3 questions, and that is cool. Bye.